All right, welcome to 2.3. This is the second day of Chapter 2. Uh, now, if we take a look at this is just a little bit of review. Hopefully everybody knows to find the hypotenuse, 3 squared plus 4 squared equals 5 squared. So 9 plus 16 is, oh, why did I say 5 squared? Just because I knew the answer right away. C squared, so this equals 25. And then the square root of 25 is 5. So the hypotenuse here is 5. In this situation, if I have 12 squared plus 5 squared equals c squared, then 144 plus 25 is equal to c squared, or we have 169 is equal to c squared, so c is 13. Now we have 8 squared plus 15 squared equals c squared. 8 squared is 64. 15 squared is 225. If I add these together, I'll get 289. And the square root of 289 is 17. All right, now if we look at these three triangles, they're three triangles that pop up quite a bit, so hopefully everybody can memorize the 3, 4, 5 triangle, the 5, 12, 13, and the 8, 15, 17. Or you can just use Pythagorean theorem each time. All right, today we're going to look at periodic functions. Periodic function is a function whose values repeat at regular intervals. Now, a cycle is a complete section of the graph that gets repeated. The period is the difference between the horizontal coordinates corresponding to the beginning and the ending of one cycle. So if we take a look at this is a periodic function because it keeps repeating values over and over again. The cycle is this loop, this section. So one cycle. Now, because it's going to start repeating again, that we can end the cycle. The period is the distance horizontally. If we take a look at this passes here at 90 degrees. It passes here at, what is this, 450? So 450 minus 90 tells us that the period for this function is 360 degrees. So that's the period. This period of the function is 360 degrees. All right, now we've already talked about sine. Hopefully everybody remembers sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. What we're going to do today is look for degrees between 0 and 360. Now, hopefully everybody remembers this between 0 and 90, because if I look at A, the opposite is 5, the hypotenuse is 13. So I can say the sine of A is 5 over 13. For the cosine, this is the adjacent side. That's the hypotenuse. So the cosine of A will be 12 over 13. Excuse me. All right, in the coordinate plane, if we take a look at this, if we draw a right triangle here, the x value will be that distance. The y value will be that distance. So this coordinate point right here is x to the right and y up. So if I wanted to find the cosine of this angle, I would take x over r. If I wanted to find the sine of this angle, I would take y over r. So let's take a look at this. Let's draw 147 in standard position and try to find the reference angle. 147, we start at 0, we pass 90, but we don't get quite to 180. So I'll draw this out here. So this is 147. Now we look at what's left over here. So if we take 180 minus 47, that's going to be 33 degrees. So that's our reference angle. So if I take a look, let's plug in to our calculator cosine of 147. Make sure your calculator is in degree mode. cosine of 147 is negative 0.8387 if I round it to 4 decimals. Now the cosine of 33, if I plug it into my calculator, is just 0.8387. Notice that the numbers are the same, just one, this is negative and this is positive. Now if we would do the sine of 147, that answer is 0.5446 positive, and the sine of 33 is 0.5446. Notice how the reference angle and the angle itself, the numbers are the same, but sometimes over here it's negative, but over here it's positive. Let's try it for 195. If I did 195, that's not my straightest line, but hopefully you can deal with it. All right, we're going just past 180 to get to 195. We're going past by 15 degrees. So our reference angle is 15 degrees. So let's find how these compare. We have cosine of 195. That's going to be negative 0.9659. The sine of 195, that's negative 0.2588. And now when I take the cosine and the sine of my reference angles, this one I get 0.9659, and the sine of 15 I get 0.2588. So here, over at 195 degrees, both of these are negative, but the reference angle is positive. But you can see that the numbers are exactly the same, other than the sign in front of it. So let's do the same thing with 305. 305 passes 270, so between 270 and 360, we'll find 305. And it looks like there's 55 degrees in there. That will be the reference angle. If we take a look at this, we have cosine of 305, which is 0.5736 if I round it. And here the sine of 305, negative 0.8192. Now the cosine of 55 is going to be 0.5736, and the sine of 55 is going to be 0.8192. Now, not to beat this point over your heads, but the reference angle is so important because the sine of the reference angle is the same as the sine of the regular angle, but sometimes it's negative and sometimes it's exactly the same. Now let's look at see where we can find positive and negative values for sine. Now if I drew some triangle in quadrant 1, now my x value here is going to be positive, my y value is going to be positive, and my hypotenuse is always positive. That's just something that we always have to remember, is our hypotenuse is always positive. Now if I wanted to find my sine of theta, cosine of theta, and tangent of theta, all of these answers will be positive because all three of our numbers that we're dealing with are positive. However, if we go into quadrant 2, we might get something different. Now, we're going to have a negative x value, but a positive y value, and then again a positive hypotenuse. So sine is opposite over hypotenuse. Positive over positive is going to be positive. Cosine over here is going to be negative over positive, which will be negative. And tangent is positive over negative, which will give us a negative answer. So in quadrant 2, the only thing that's going to be positive is sine. Cosine and tangent are both going to be negative in that quadrant. Let's check out quadrant 3. we know the x value is negative, the y value now is negative, but the hypotenuse is positive. The sine of theta is opposite over hypotenuse. So the opposite is negative, hypotenuse is positive, so that's going to produce a negative answer. The adjacent is negative, hypotenuse is positive, so that's going to be negative. But the tangent is opposite, which is negative, over adjacent, which is negative. Negative over negative gives us a positive. Finally, quadrant 4. If we draw out the triangle, it's positive x, a negative y, and a positive hypotenuse. So our sine of theta is opposite over hypotenuse, which will be negative. Our cosine of theta is going to be positive over positive, which is positive. And our tangent of theta is going to be opposite over adjacent, which is negative. So if you look up here, in quadrant 1, all are going to be positive. In quadrant 2, sine is the only one that's going to be positive. Quadrant 3, tangent is going to be positive. And the last quadrant, quadrant 4, cosine. Some people try to remember this by saying all scholars take calculus. Saying that in this quadrant, all of these are going to be positive. In quadrant 2, just the sine is going to be positive. That's where we get the S. Quadrant 3, the tangent is going to be positive. In quadrant 4, the cosine is going to be positive. Now, if the terminal side of the angle theta contains the point 8, negative 5, try to sketch this and find the hypotenuse. All right? So 8, negative 5, that means we move to the right 8, and then we go down 5. So somewhere over here. So we want to use, so we know this goes 8 to the right and 5 down that way. So first it said find the hypotenuse. So we can say 8 squared plus 5 squared equals c squared, which is going to be 64 plus 25, which is going to be 89. Now I'm pretty sure we can't reduce 89. It's just going to be the square root of 89. All right. So now if I want to find the sine of theta, it'll be the opposite, which is 5, over the square root of 89. Now we can rationalize that by multiplying by root 89 over root 89, which is 5 root 89 over 89. Now the cosine, now I made my biggest mistake. That 5, since it's going down, should be negative, so we should have a negative there and a negative there. Hopefully that doesn't mess anyone up. Now if I do cosine, cosine is going to be my adjacent side, which is 8, over my hypotenuse, which is root 89. So if I do the same thing by multiplying root 89 on both sides, I'll have 8 root 89 all over 89. So I can find my sine and cosine at that point. Now we want to find the terminal side of theta that passes through the point negative 3, 7. So that means I go 3 to the left, 7 up. Now we got to find our hypotenuse. 3 squared plus 7 squared equals c squared. 9 plus 49 is 58. Take the square root of 58. So we'll just leave square root of 58. Now we want to find the sine and cosine. The sine of theta is going to be the opposite, 7 over root 58. We rationalize by multiplying root 58 over root 58. So our answer is 7 root 58 over 58. For cosine of theta, It's going to be my adjacent side, which is negative 3, over my hypotenuse, multiply by root 58 over root 58, and I'll get negative 3 root 58 all over 58. Alright, so now I want you to graph sine of theta on your calculator. Now do that with x-min at negative 60, x-max 720, y-scale of 30. Let's go from negative 4 to 4 on the y's, and let's go up by 1. Now when you do this in your calculator won't let you type in theta, so just do y equals sine x. Now if we put a 4 in front of sine, hopefully you see that that's going to be a vertical stretch. That's supposed to be an h by a factor of 4. So that's just going to take it, stretch it up to 4, go down to negative 4, up to 4. So it goes up from 4 down to negative 4. Now, there are two transformations here. This is a vertical stretch by a factor of 2. And we're going to move it to the right 30. So we're going to, do I have a slide over here? Yeah. We're going to move it to the right 30. So we start 30 degrees over. And then it's going to, the sine starts here, goes up, comes down, goes back there. Now we said the sine does this in 360, so this would be 390. Now we can continue this graph as is. And that will be a good graph of this. Now here's your homework. Good luck.